Hello everyone. In this video, I'm going to discuss the last 10 questions of this paper 1-3 May-June 2021 CAIE. Question number 31. Two resistors of resistances R and 2R are connected in parallel with a battery of electromotive force 12 voltage and negligible internal resistance. The total power dissipated by the two resistors is 36 watt. What is the value of R? So you need to find out the value of R. So here it is given that R and 2R are connected in parallel. So in the case of parallel connection, the total resistance would be equal to the reciprocal of the first one plus the reciprocal of the second one. This is the equation that we follow. You can name it as R1 and R2 as well. So here the total resistance is what you need to find out first. Okay, so the total resistance is equal to 1 divided by the total resistance is equal to 1 over R plus 1 over 2R, which is equal to 2R plus R divided by 2R square. So here in the numerator 2R plus R is 3R, and in the numerator we have 2R square. So R and R get cancelled, so the value is 3 by 2R. So this is equal to 1 by R, so R is equal to 2R divided by 3, right? So this is the total resistance value, and we have the total power dissipated. So the power value in terms of voltage and resistors, the equation is V square divided by R, right? So the V value is already given, 12 voltage. So 12 square divided by the R value, 2R divided by 3, so here it will be multiplied by 3, right? So this is equal to 36 watt. So we can rearrange to find out the R value. So R is equal to 12 square times 3 divided by 2 times 36. So if you are doing the calculation, the value that you are getting would be 6 ohms. Okay, so for the question number 31, the option D is the correct answer. Question number 32. A wire has a length of 3 meter and is made of metal of resistivity 4.9 times 10 to the power minus 7 ohm meter. A potential difference of 12 voltage is applied across the wire so that it has a current of 1.4 amperes. What is the cross-sectional area of the wire? So here in this question, we can use the formula Ohm's law and the equation of R. So here R is equal to rho L divided by A. So here A is what you need to calculate, and rho value, the resistivity value is already given, length is already given, but we don't know the R value, right? So here it is rearranged in a way here like this. Okay, so here we need to find out R. For finding it, we can use the Ohm's law. V is equal to IR, R is equal to V over I. So the voltage is 12 divided by the current is 1.4, which is equal to 8.57 ohms. Okay, so here now we have all the values that we need. So please substitute those values. Multiplied by 3 divided by the resistance value that you calculated is 8.57. Okay, so do the calculation and you will be getting that value as 1.7 times 10 to the power minus 7 meters square. So this question number 32, the correct option is option B. Question number 33. A cell of negligible internal resistance is connected in series with a thermistor, a fixed resistor, and an ammeter. Okay, so let's consider like this, which is more easier. Okay, so here's the symbol for thermistor and a physical resistor, and there is an ammeter. So these components are connected in series. The thermistor is placed in a beaker of water and the temperature of the water is slowly increased. A graph of current I against the temperature T of the thermistor is plotted. Which graph could show the variation of I with T? So here we have the thermistor. So in the case of thermistor, as the temperature increases, the resistance will decrease, right? So that's the property here. So we know that the resistance over in this case would be decreasing. So the potential drop across this also be decreasing, right? So more current will pass. Since the resistance is low in the series circuit, the current passing would be greater, right? So the current will be increasing as the temperature is increases. Okay, so current will be increasing in this case. So previously it was having a particular value of current, and as the temperature increases, resistance of this thermistor decreases. So resistance of the whole circuit is decreases and the current value would be increasing. So according to this thing, only this option B is showing the correct variation. So in this question number 33, option B is the correct answer. Question number 34. A battery with internal resistance is connected to a parallel arrangement of two resistors and a switch S as shown. Initially, switch S is open. Okay, so this one is open, so the current will pass through only this way. Okay, only this way is the correct passage. What happens to the voltmeter and ammeter reading when switch S is closed? So here the switch is actually a safety mechanism, and the switch is having a really low resistance so that the current will be passing, right? So when it is connected, when this wire is connected, the current will be flowing through this resistors, right? So this resistors, and this would be the path the current would follow. Okay, not this one. So in this way, the resistance value would be less comparing to the previous case. So as the resistance is less, the current would be more and the voltage would be less. The potential drop across this would be less, right? So the voltmeter reading will decrease and the ammeter reading will increase. So the option A is the correct answer. Question number 35. Kirchhoff's first law states that the sum of currents entering a junction in a circuit is equal to the sum of the currents leaving it. The law is based on the conservation of a physical quantity. What is this physical quantity? The physical quantity is charge, since the current is the flow of, or the rate of flow of the charges. So option A is the answer. Question number 36. Two resistors have a combined resistance of 34 ohms when connected in series. The same resistors have a combined resistance of 7.4 ohms when connected in parallel. What is the resistance of one of the resistors? So in this question, let's take these two resistors are X and Y. Okay, so the first option is these are connected in series. So when they are connected in series, the total resistance would be the sum of the resistors. So X plus Y is equal to 34 ohms. Right, so the same resistors is now connected in parallel. So in the case of parallel connection, 1 by R would be equal to 1 by X plus 1 by Y, which is equal to X plus Y divided by XY. Or you may say that the R value is equal to XY divided by X plus Y. Right, so here this parallel combination, the resistors would be equal to 7.4 ohms, right? So we have two equations. This is equation 1 and this is equation 2, right? So here it's given X plus Y. So let's substitute this equation 1 in this equation 2. So 7.4 is equal to XY divided by X plus Y. Instead of that, we can substitute 34, which means that xy is equal to 7.4 times 34, which is equal to 251.6. so this is equation number 3. So xy is equal to 251.6. okay, so this is equation 3. So here, in order to find out the value, just rearrange this formula to find y, which is 251.6 divided by x. Okay, so now substitute this value in this equation number 1. So what you will be getting? Here x plus, instead of y, just substitute this value, which is 251.6 divided by x, which is equal to 34 ohms. Okay, so here just multiply the whole equation with x. So here x times x is x square. Here x is in the numerator and denominator, so they will cancel out each other. So 251.6 is equal to 34 times x. Okay, so this is the equation, and we can rearrange like this, so that you are getting a quadratic equation. So now you have a quadratic equation, and in that equation a is equal to 1, b is equal to minus 34, and c is equal to 251.6. okay, and to find out x value, please use the quadratic equation to find it, which is minus b plus or minus root of b square minus 4ac divided by 2a, which is equal to minus b minus 34, which is 34 plus or minus root of b square, so 34 square minus 4 times 1 times 251.6 divided by 2 times 1. So if you're doing the calculation, the value of x would be 23 ohms. So here the option C is the correct answer. You may find out y value also. You just have to substitute in this formula, like 251.6 divided by 23, you will be getting 11 ohms. Okay, so for this question number 36, option C is the correct answer. Question number 37. A potential meter circuit is used to investigate the electromotive force EMF of a cell X. The EMF of a cell is known to be approximately 0.50 voltage. Okay, so this X value. The driver cell has negligible internal resistance and an EMF of 2 voltage. The sliding contract is moved along the uniform resistance wire between ends Q and R to a point P, where the reading on the galvanometer is 0. What is an expression for the approximate length of QP? In this question itself, it's given that it is balanced. So the potentiometer is now balanced and the voltage is distributed. Here, see, this driver cell is connected to this whole resistance wire, which is uniform, right? So the voltage is distributed throughout this length, or it's a resistance wire. It's having a particular resistance, right? So according to this resistance value, there will be a potential drops throughout this length, right? So we can use this formula: V1 divided by V2 is equal to R1 divided by R2. So here the two potentials are one of the driver cell and another one of the unknown cell. Okay, and the resistance is this length. The length of the resistance wire would be equal to the resistance value, or it is proportional to the resistance value, right? So here I'm taking this one subscript for mentioning the driver cell. So V1 is 2 voltage and R1 is that length of this resistance wire, the total length QR, right? Then V2 is that unknown resistance which is having a voltage of 0.5 and the length where it is distributed. So if it's the galvanometer is showing the 0 reading, which means that there is no current driven. So the voltage is distributed throughout this length. The voltage of this unknown resistance is distributed throughout this length, right? So the length is QP here, right? And you need to find out this QP value. So do rearrange. QP is equal to QR divided by 2 and multiplied by 0.5, which is 1 by 2. That is QR divided by 4. So the option A is the answer. Question number 38. The table contains data for 4 different nuclei P, Q, R, and S. Which 2 nuclei are isotopes of the same element? Isotopes are nuclei of the same element with different number of neutrons but same number of protons. So here we have the neutron value and the nucleon number. So the nucleon number is basically the sum of proton number and the neutron number here. So we can find out the proton number for each nuclei. Okay, so here it is 5 neutrons and 10 nucleon number, which means that 10 minus 5 is the number of protons. Here is 10 minus 6, so 4, and here is 14 minus 6, which is 8, and here 16 minus 8, which is also 8. So R and S are having the same number of protons but the different number of neutrons, which means that R and S are isotopes of the same element. So the option D is the correct answer. Question number 39. Which statement about beta minus decay is correct? So here it is given that which particle is splitted, changes to given of this beta particle. So beta decay occurs when there is an imbalance of protons and neutrons in the nucleus, usually too many neutrons. So beta minus decay is more, like probability is more comparing to beta plus decay. A neutron will then decay into a proton, which is positive, and an electron, which is negative, and an electron antineutrino. The proton remains in this new nucleus and the electron is expelled at a very high velocity. So since it is having some energy, we need some other particle to conserve the energy. That's why we are having an electron antineutrino in this beta decay. And we know that we have beta plus decay and beta minus decay. So in the case of beta minus decay, neutron is decayed into electron. In case of beta plus decay, proton is decayed into positron. Okay, so which one is giving you the similar answer? So the question number 39 is having a correct answer of option A. So the last question of this paper, question number 40. What is the quark composition of hydrogen 3 nucleus? So here the quark composition we can find out using this proton and neutron, because it's a hydrogen nucleus, and using this we know that there is 1 proton and the nuclear number is 3, which means that 2 neutron are there. So proton is having 2 up quark and a down quark. So up quark and a down quark, and here there is 2 neutrons, right, which is UDD. So 2 UDD. So here is 4 up quark and 5 down quark. So the option A is the correct answer. So by this we have finished this paper 1-3 of May-June 2023. I hope you guys enjoyed. Thank you.